Hello, family. Welcome to another session of Maths Fanatics. In this video, we're going to be looking at limits that involve absolute values. Okay, perfect. So now let's look at A together, right? On A, ladies and gents, this limit, right? This limit as x approaches 0 of this absolute value, something will happen here. I already broke it down here, but I'll explain it, how I did it. So this one, right? This part here, you see, is not saying as whether we're moving from the left or the right. So we are going to break it into two parts. The limit as x approaches 1 from the right, and the limit as x approaches 1 from the left. Remember that negative means from the left, that means from the right. Okay. Remember, as we move from the right, it means we are coming from the positives, because whatever x value we're going to put there will be bigger than 1, because we're approaching 1 from the right. So it means this number here will come out as positive. But in simple terms, as you're approaching the right, as you're moving from the right, the absolute value is also positive. You see, as you're moving from the left, the absolute value becomes negative. That is very important to know. And then remember, we always try to substitute. If I try to substitute here, I get 0 over 0. Especially at the bottom, it's positive 1 minus 1 is 0. Even here, it's positive 1 minus 1 is 0. So I know that there's something I need to do. Ne? And the good thing here when I look is I can see that, okay, the bottom can be factorized. The top can be factorized. 2x minus 1. Sorry, this is still limit as x approaches 1. And then x plus 1 over x minus 1. And this one can be simplified as well. Limit as x approaches 1 from the left can be turned into that, and then x plus 1. Then here you have negative x minus 1. And ladies and gents, you can see that this guy here will cancel with that guy. You can see that this guy will cancel with that guy. Right. Now we can do our substitution. I'm going to take this x value of as it approaches 1 and replace that with 1. So the answer is 2 on this side. So the right-hand limit is positive 2. Let's check the left-hand limit. I'm going to take positive 1 and substitute there. I'm going to have negative 1. Oh, this negative is there, right? Is this one. So this side I have negative 2. Therefore, the limit do not exist. Because the left limit is not equals to the right limit. So you have to give a reason for your answer. You're going to say, because it's like this, because limit as x approaches 1 from, I'll just call that function f of x, is not equals to limit of f of x as x approaches 1 from the left. Then we cannot evaluate the limit basically, as it does not exist. Okay, so now we can do the next one. The next one, we are approaching negative 2. So I'm also going to break it into 2. So I have limit as x approaches negative 2 from the right. Then this side, I'm going to have limit as x approaches negative 2 from the left of that function, right? But remember, I said if it's positive, the absolute value becomes positive. So I wrote 1 and x squared, but the absolute value became positive. Now let's check this side. If it's negative, the absolute value becomes negative. So we're coming from the left. So it's negative x plus 2. The rest that does not have absolute value will stay the same. X squared 1. Right. Now we can do substitution. Here, I'm going to substitute negative 2. If I substitute -2 there, I'm sure we can see that this guy here, Sx gets closer to -2. Basically, here you're approaching what? You're approaching infinity because you have a constant at the top, and then this gets smaller, and this guy here will get smaller and smaller and smaller. It keeps on approaching 0. So basically, when I have infinity plus 4, which is just infinity, right? So the right hand limit is infinity, right? And then let's check the left hand limit. The left hand limit will also give you infinity. You see, because if I put -2 here, this will be positive. What happens here? Let's see actually. So if I put -2 here, we're approaching what? We're approaching 0 there. And as I'm approaching 0, it means this whole thing gets bigger and bigger because I'm dividing with a very small number, right? So I'm also approaching infinity, right? Therefore, the solution for this will be infinity. But this one is negative infinity, do you see? So the answer will just be infinity, basically. Awesome. Perfect. And then we can try C. I'll just do C here. On C, I can see that I'm already moving from the left, right? So that given, I can write my limit as this limit as x approaches 3 from the left, it's x squared. Then I'm going to have negative x minus 3. Remember, this negative will always correspond with the one that was on the absolute value. And then over x minus 3. Then I'm sure, ladies and gents, you can see that this guy will cancel with that guy. So you're basically left with the limit as x approaches 3 from the left of negative x squared. This negative will multiply with that, which is -3 squared, which is -9. So the answer for C will be -9. Right. Awesome. So now let's try the next question. On the next question, they say we need to determine the value of the parameter k to make the following limit exist and finite. So the limit must exist and be finite or finite. Right. Okay. So I see that, okay, if I were to substitute 5 here, I'll get 0, which is undefined. And I can see that, okay, at the top, I must have a rational function. So the first step that I'm going to do here is this. I'm going to say limit as x approaches 5. Then here I have x minus 5. Okay, so I know that, remember the rule is if I want to substitute here and I get 0, usually I have to factorize the top. So and I can see that here it's x squared, so I know that the top must be a trinomial then. Then I'll open 2 brackets. And I know that one of the brackets must be exactly the same as the bottom, so they can cancel each other. So this will cancel that. Then here I must have x plus 4, so that I still get -20 when I multiply those. Awesome. Then now let's find limit as x approaches 5. This trinomial on top refers to x squared minus 5x plus 4x, which is going to be minus 1x. What am I doing there? Sorry. So it's going to be minus 1x minus 20. Then you have x minus 5. And then you can easily see that your k is there, right? That's where your k is there. Therefore, k equals to -1. All right. Then we're going to say limit. They want us to evaluate the limit, so we're going to go back there. This will cancel that. So left with limit as x approaches 5, x plus 4. which equals to 5 plus 4, which is 9. And that's finito, ladies and gentlemen. If you found this video helpful, please don't forget to hit the subscribe button for more fire content and to share with family and friends. Aluta continua. Tango.